Hey guys, this is going to be the video for the 3.5 homework. We're just going to be doing a lot of factoring and solving. So, yeah, let's jump into it. So, for the first 5 problems, it says solve the equation. So whenever I solve them, I see that these are equal to 0. So I'm trying to find the values of x that when I plug into this equation, it will be equal to 0. I can immediately see here that if x is equal to 0, then the entire equation will be 0. So that's one of them, but there's going to be more. So let's factor. So I see the greatest common factor here is x. So if I take that out, I'll get x squared minus x minus 12. And that's going to be equal to 0. And here you can see that, well, I guess I'll get that in the next step. This is a trinomial, so it is still factorable, and it's going to factor into 2 binomials. First terms have to be x because the first term here is x squared, so those need to multiply to be x squared. And these 2 values need to multiply to be negative 12, but they also need to add to be negative 1. So I think that's going to be negative 4 and positive 3. Okay, so now that I have these 3 factors right here, they're set equal to 0. I need to find, this is the easiest way to find out what values of x will make all this equal to 0. Because these are being multiplied. You can think about it as a times b times by c. These are all being multiplied, and they're all equal to 0. And so if a times b times c, or x times x minus 4 times by x plus 3 is equal to 0, then one of these has to be equal to 0. The only way to get a 0 from a product is if one of them is 0, right? So let's think about this first one. What would have to be the value of x here to make it equal to 0? Well, that would have to be 0. If this is 0, if this is 0, if this is 0, it doesn't really matter what these become because this will be 0, and I'm multiplying, so all of it will just become 0. So x equals 0 is a solution here. Now, what about the next factor? We have this one right here. What would have to be the value of x here to make this equal to 0? Well, that would have to be 4, because 4 minus 4 is 0. And then if I have 4 here and 4 here, it doesn't matter, because this will be 4 times by 0 times by 7. But the thing is, this becomes 0, so it all becomes 0 when I multiply. So when x is equal to 4, the polynomial will be equal to 0. And then when x is equal to negative 3, if x is equal to negative 3 here, this becomes 0. If x is equal to negative 3 here, this becomes negative 7, and this becomes negative 3. But when you multiply them all together, it's all going to be equal to 0. So these are the 3 values of x that will make this equal 0. And it's just easier to see if you can factor it because of the 0 product property. Moving on to 2, I see that it's not equal to 0. So I'm going to move this over here. So this is 2x to the 4th minus 4x to the 3rd plus 2x squared equal to 0. So I just moved this to the other side as a positive. Now it's equal to 0. And then something I can do, I can factor, there's greatest common factor of 2x squared. So I'm going to take out a 2x squared. I'll be left with x squared minus 2x plus 1, and that's going to be equal to 0. And I have a trinomial here, so I'm going to see if I can factor that into 2 binomials. First terms would have to be x and x. X times x is x squared. Now I need 2 numbers that multiply to be 1, but add to be negative 2. So that's going to be negative 1 and negative 1. Okay, so now that I have it completely factored, again, let's look at this right here. I have a times b times by c. So what would have to be the value of x here to make everything equal 0? It would just have to be 0. If x is equal to 0, this becomes 0, this becomes -1, this becomes -1, but when I multiply them all together, I get 0. So x equals 0 is a solution, and then x equals 1 will be the other solution, because if x is equal to 1, this becomes 1 minus 0, which is just, 1 minus 1, which will just be 0. This will also be 0. This will become 2 when you multiply it by 1 times by 2. But in any case, all this just becomes 0. So x equals 1 is another solution. For 3, I'm going to subtract that 50w. So I'll have 5w cubed minus 50w equal to 0. I'm going to factor out a 5w, and then I'm going to get w squared minus 10. That's going to be equal to 0. Right, if I take out a 5, yeah. Okay, so this can't be factored anymore. But I do have a squared, so what would w have to be here in order for this to be equal to 0? So if you can see it, it's you can see that this would have to be 10. So I want this whole thing to be 10 for this to become 0. But w, that doesn't mean w has to be 10, because if w is 10, that becomes 100 minus 10, which is not 0. So I want w to be square root of 10. So if w is equal to the square root of 10, then it works. Another way you can look at it is, let's say we take w squared minus 10, and let's just make it make this into an equation where it does equal 0. Now let's solve for w to see what it would have to be. So let's add a 10 to the other side. I would get w squared is equal to 10, and I would take the square root of both sides. So take the square root, and so this would be w is equal to, now we're going to say plus or minus the square root of 10, because if I take, so again, the idea is if I plug this back into w, I should get 0. So if I do square root of 10 squared minus 10, so notice here that I'm just plugging in square root of 10 into w. I'm squaring it, and then I'm subtracting 10. Well, the square root of 10 squared is going to be 10. These are inverse operations, square root and squared. So this becomes 10 minus 10, which becomes 0. But also, if I plug in negative square root of 10, so if I plug in negative square root of 10 minus 10, this right here is still going to be positive 10, even though it's negative, because we're squaring it. So 10 minus 10, which is still going to be equal to 0. So I can see that both positive and negative square root of 10 is going to work here. So there's 2 solutions, and then the other one would have to become here, and that's just if w is equal to 0. So if w equals 0, this is also a solution. Yeah. Alright, so for 4, I see these terms over here. I'm going to move them over. So we get 2x to the 4th minus 6x cubed minus 12x squared plus 36x equal to 0. Did I get that right? Yeah. I can factor out a 2x, so take out 2x. I'm going to get x to the 3rd minus 3x squared minus 4x plus 9. That's going to be equal to 0. And I see 4 terms here, so I'm going to do factor by grouping. So 2x, and I'm going to take out an x squared. I'll be left with x minus 3. And I can take out a negative 4, right? No, I can't take out anything. So this right here might not be factorable. Yeah, the greatest common, so if I take out a 4 here, if I take out, wait a minute, we took out a 2, right? So if we take out a 2, this becomes just x to the third. If I take out a 2 here, that becomes, if I take out a 2 here, that becomes 6, not 4. So if I take out a 2, oh man, I totally was thinking of a different number when I factor that. If I take out a 2, this becomes negative 6x squared, negative 6x, because I'm also taking out an x. If I take out 2 there, that becomes plus 18. Okay, did I get that? Now let's FOIL this back in and see if I get the same thing here. So 2x times by that's going to give me, yep, that's going to give me negative 6x to the third. That's going to give me negative 12x squared. Yeah, okay, so I think I finally factored correctly. I can take out a negative 6 here, and I'll get x plus 3. There we go. Okay, and then finally I would have 2x minus 6. One second. Both of these sides have an x minus 3. Man, I'm struggling today with my factoring, because I took out a negative, and if I take out a negative, that becomes negative. So I can take out the x minus 3, that's on both sides. I'll be left with x squared minus 6, and I have a 2x right there. That's all equal to 0. Okay, finally, I think I've factored everything I can. Let's just go through A, B, and C and see what value of x I need to plug in to get 0. So here, obviously, is just 0. 2 times by 0 is 0. And then this becomes negative 3. This becomes whatever that becomes. But because I'm multiplying by 0 here, everything becomes 0. So x equals 0 is a solution. Let's say for this factor right here, x would have to be equal to 3 in order to get a solution. And then here, x would have to be equal to plus or minus the square root of 6. So x would have to be equal to plus or minus the square root of 6. If that's not as easy to tell, just take this right here. We'll say x squared minus 6 equals 0. X squared is equal to positive 6, and I take the square root of both sides. I get x is equal to plus or minus the square root of 6. All right, and finally we got this one right here. I'm going to move these terms over, so I'm going to add, that's going to give me x to the third plus 12x squared plus 48x plus 64. Now, I think I can already tell that this is not going to be factorable by grouping. I see these 4 terms and I might want to do that, but the greatest common factor here is just x squared, and I'll be left with x plus 12. The greatest common factor here, well, might be 2, 3, I don't think, well, if, sorry, that should be 12. If I want to get x plus 12 on this side right here, I can't, because I'd have to factor out a 48 for that to become x, but this is not, 64 does not have a factor of 48, nor would, even if I did take it out, I wouldn't get x plus 12. So this is not factorable. So what we can do is use the rational roots theorem, which says if I take all the factors of 64 and divide it by all the factors of 1, I can create a list of possible factors. But yeah, so I'm not going to do that. So I mean, I could, but yeah, I'm just going to graph this. So this is another way that you can find possible zeros. So we have, let's see, what do we have? X to the third. And then plus 12x squared. Plus 48x. And then plus 64. Okay, so here I see that it crosses the x-axis at -4. And so that's something I can start with. So -4 is a solution. I found that through graphing. So let's take the -4 and let's divide it. So I got 1, got 12, got 48, and I got 64. I'm going to use synthetic division, drop the 1, that becomes -4, that becomes 8. 8 times -4 becomes -36. Subtract those together, that becomes 12, doesn't it? Wait, did I do that right? Yeah, that becomes 12. But that... -4 is a solution here. Got 3, 2, 1, 0. Got positive 12, 48, 64. Drop the 1. I know negative. I'm using -4. 1 times -4 is -4. -4 and 12 is 8. 8 times by 4. Did I do that right? My times tables, not knowing my times tables, is coming back to get me. 32. That's what it is. Okay, so that's going to change that right there. That is going to become 48 minus 32. It's going to become 16. 16 times -4 is going to become -64, and then that becomes 0. So there we go. Okay, so then this is the polynomial of x squared plus 8x plus 16 plus 16, that's equal to 0. That can be factored to be x minus 4 and x minus 4, because x times x is x squared. -4 times -4 is positive 16, but -4 minus -4, this should be plus. There we go. Okay, and so there you go. X equals -4 is the only solution here. X equals -4 is the only solution. It'd be -4 for both those factors, and we used it here. So x minus 4 is the only solution here. Okay, still doing the same thing, except now we're going to be using a graph. So let's go ahead and take a look here. Let's factor out an x squared here. And this becomes x squared plus x minus 6. That's going to be equal to 0. I can still factor the trinomial there, so I'm going to get x squared. I'm going to get x plus 3 and x minus 2. That's going to be equal to 0. So x would have to be equal to 0, -3, and 2. So now, if for all this to be equal to 0, those would have to be the values of x. So now these are also my x-intercepts. So at x equals 0, at -3, and at positive 2. Okay, now I also see that this is a even degree positive coefficient. So the end behaviors tell me that I have to go this way. So at the ends, where these points are, has to go up. Okay, so I know here that it's going to have to come down, and it's going to have to come, at some point, it's going to have to turn back around. It's going to have to, now at this point right here, it's worth noting that because I have two factors of x right here, so this is x times by x. This is a multiplicity of 2. And if I ever have an even multiplicity, that means at that x-intercept, it will only touch, but it will not cross. Okay, now I also would kind of want to know how far down it goes. So if you can graph this into a table and see what are the values at -2 and at -1, you can do that. Or at 1, you can also do that. So, but I just have a calculator here, so let's just use this right here. So we said, let's take -2 and let's plug that in here. So we have -2, that's going to be raised to the 4th power, plus plus negative 2 raised to the third power minus 6 negative 2 squared. And that becomes negative 16. So I know it's going to come down to that point right there. And then let's go ahead and put in 1. So we're going to do, well, I can do that here. I don't need a calculator for that. So if I put in 1 here, this becomes 1 plus 1 minus 6. So that becomes 2 minus 6. That becomes negative 4. So at 1, it's going to be negative 4. So let's say here, we're going to come down at least to this. It could still go down further. And then it's going to go up. It's going to touch right there. It's going to come back down. It could go down further than that point. But we'll just say something like that right there. Okay. Let's try this one right here. So I'm going to factor this. I see 4 terms. So I'm going to factor by grouping and hope that it works. I'm going to take out a negative x right here. And I'm going to negative x squared. And I'm going to get x plus 1. Here I can take out a 9. And I'm going to get x plus 1. Okay, so I see both sides have an x plus 1. And then I'll be left with negative x squared plus 9. Now, here, I don't like it when my leading term is negative. So I'm going to take out a negative 1. So I'm going to make it negative 1, x plus 1, and that becomes x squared minus 9. And that's easy because this is factorable right here because it's minus. So I have negative x plus 1, and then I'll have x plus 3 and x minus 3. That's the pattern there, difference of squares. And then I can see that my solutions are x equals negative 1, x equals 3, and x equals negative 3. So those are my my x-intercepts, so negative 1, negative 3, and 3. Now, let's see, none of them have a multiplicity, an even multiplicity. They all occur only once. So that means they will all just cross. Now, in behavior, this is a negative leading coefficient and an odd degree. So that means on the far left, it's supposed to be going up, and on the far right, it's supposed to be going down. And in between, it's going to come down, it's going to have to come back up, it's going to go up, and it's going to have to come back down. So let's put negative 2 into the function here. I'm going to do a little shortcut. So negative 2 stores x. Okay. So we had negative x to the third minus x squared. Then it was plus 9x plus 9, I believe, right? Yeah. So that's negative 5. So at negative 2, it was at negative 5. So we'll say right there, it's going to come down, come back up. Okay, and then let's go ahead and plug in 1. So if I plug in 1 right here, this becomes negative 1 minus 1 plus 9 plus 9. I plugged in 1. Yeah, I plugged in 1. So that becomes, this right here becomes 18 minus 2. It becomes 16. So we'll say that it goes up to about right there. Okay, and there we go. I know it says don't need a graph for 8 or 9. Okay. Okay. Let's see. We're just going to solve these right here. So we're going to set equal to 0 rather than p of x. And then we're going to factor. So we're going to take out an x to the fourth first of all. We're going to be left with x squared minus 11x plus 30. I have a trinomial here. So let's see if I can factor that into two binomials. So starting with x, and then are there two numbers that multiply to be 30 and add to be negative 11? So for 30, that's 1 and 30, 2 and 15, 3 and 10, 4, not divisible by 4, 5 and 6, negative 5 and negative 6, so negative 5 and negative 6, and so x equals 0 would be a solution, x equals 5, and x equals 6. Those are the three solutions there. And then this has a multiplicity of 4. All right, here, I think negative 4 is a greatest common factor, negative 4x squared, and I'll be left with x squared minus 2x plus minus 15. So minus 15. So negative 4x squared. Okay, let's see. So we're going to have x and x. What two numbers multiply to be negative 15 and add to be negative 2? That's got to be 5 and 3, right? It'd have to be minus 5 and plus 3. So x would have to be equal to 0, x would have to be equal to 5, and x would have to be equal to negative 3. So those are the three solutions there. Oh my, there's a lot of factoring here. Okay. For 10, find all the real solutions of the equations. So this is not going to be factorable through that's not going to be factorable through grouping. So I'm going to throw this into Desmos and find a 0. It's kind of cheating, but what the heck. So x to the third plus x squared minus 17x plus 15. The thing is, why it's cheating whenever you graph is because I can see all the zeros. So I can see the zeros are negative 5, 1, and 3. So, but I'm just going to pick one of them and find the rest through factoring. So that's going to be the work that I'm going to be showing. So I'm just going to take negative 5 because that's the far left 0. I could really take 1 or 3, doesn't matter. And then use some synthetic division. Drop the 1. 1 times negative 5 is negative 5. 1 and negative 5 add together to be negative 4. Then I get 20. I get 3. Get negative 15. I get 0. This is x squared minus 4x plus 3. And then I'm going to factor that more. I'm going to get x minus 3 and x minus 1. And then, so my solutions are x equals 3, x equals 1, and x equals negative 5. So those are the three solutions there. All right, I have another polynomial, not factorable through grouping. Let's go ahead. I'm going to graph it just to find one of the zeros. So 1, 2, 3, negative 10x, x squared, plus 19x plus 30, plus 19x plus 30. So those are the three solutions. I can see them already. Let's just take the one on the far left, do negative 1. So we got 1, negative 10, 19, and 30. So drop the 1, get negative 1, get negative 11, get positive 11, get 30, get negative 30, get 0. So I have x squared minus 11x plus 30. I can factor this to be x minus 5 and minus 6. So x would have to be equal to 5, x would have to be equal to 6, and x is equal to negative 1 from there before. And that's already confirmed with my graph right there. Okay. I'm going to let you guys do 12. Yep. I'm going to do 13. So for 13, I'm going to get a 0 by graphing it. So we had 2x to the third minus 3x squared minus 50x minus 24. Okay, so I see -4, -1/2, and 6. So let's just use -4. So -4, we have 2, -3, -50, and -24. So 2 times -4 is -8. That becomes -11. That becomes 44. That's -6. That's 24. That's 0. So I get 2x squared minus 11x minus 6 equal to 0. Now I need to factor this. It's a trinomial, so we're going to have two factors. Now this has to start with 2x instead of x, and this has to be x because those multiply give me 2x squared. These numbers here multiply to be -6, but they also need to add to be -11. So what are two numbers that multiply to be -6? Oh wait, no, not add to be -11. So only multiply to be -6, and we have to figure out which of these would add to be -11. So I'm going to say -6 here and +1 here, and let's check here. I think that's right. So this becomes -12x. This becomes plus x, but when you add them together, it's going to be equal to -11x. So it checks out. Okay. And then here, I'm going to do 2x plus 1 equals 0 and subtract the 1. So I get 2x is equal to -1 divided by 2. So x is going to be equal to -1/2. And here, x would just have to be equal to 6. We also know x is equal to -4 because we found that when we graphed it. And we confirmed these right here by looking at the graph. Okay. All right, let's try 4. Let's see. I'm going to graph 4 and see if I get any weird numbers. If it don't, then I'm going to leave that for you guys. So x to the third minus 2x squared minus 23x and plus 60. Okay, nope, nothing crazy. So just take one of those zeros, use synthetic division, and factor. Let's try 15. So we have, was that x to the fourth? Nope, still x to the third plus 10x squared plus 31x. I think it was plus 30. Okay, nothing out of the ordinary there, so you can do that one just fine. Try 16, so we have 2x to the third minus x squared minus 27x plus 36. Okay, so we do have a decimal 1.5, so let's do this one. I'm going to use 3 here. That was one of the x-intercepts shown on the graph. Let's find the other two. So 2, -1, -27, and 36. Drop the 2. 2 times 3 is 6. This becomes 5. That becomes 15. That becomes -12, -36, and 0. So I get 2x squared plus 5x minus 12. Okay, that's okay. And then can I factor this? If I can, the leading terms of my binomials will be 2x and x because those multiply to be 2x squared. these have to multiply to be negative 12, but add to be 5. Oh, right, not add to be 5. They need to multiply to be negative 12, but add to be negative 24. So, not even add to be 5, not even add to be 24. I don't know what I'm even saying. These two numbers have to multiply to be negative 12. But the inner and outer terms, when multiplied, have to add to be 5. That's what I meant to say. So, negative 12. Also add 2 times 4. 4 and 3. 2 times 4. That would work. So if this right here was plus 4 minus 3, because that multiplies to be negative 12. These two multiply to be 8x, but this adds to be negative 3x, and those combine to be 5x. So yeah, that works. Perfect. Okay, and then 2x minus 3, I'm going to set that one equal to 0. I'm going to add a 3 to the other side. So I get 2x is equal to 3, divide by 2. So x has to be equal to 3 halves. And here x would have to be equal to negative 4. And we know x is equal to 3 from using this right here. Okay, there you go. Okay, so here, for these ones, we are trying to find the value, we're trying to find the function that gives these zeros. So if these are the zeros, then the factors would have to be x plus 2 times by x minus 3 times by x minus 6. Because if these are the factors, then these are the zeros. Now you just have to multiply these out. So I'm honestly not going to do that because that's something from the last unit and something that you guys should be familiar with. So you need to multiply those out. And you'll do the same thing here. So you know x plus 4 is a factor, x plus 2 is a factor, and x minus 5 is a factor. So you need to multiply those three out and get the function, the polynomial. Okay, so here I can do this one. I think we edited this one. So I said that if negative 2 is 0, if square root of 7 is 0. Now by implication, you must also know that if square root of 7 is a 0, remember that square roots always come in pairs whenever they're solutions. So negative root 7 is also a 0. So my three factors that I'm going to have is going to be x plus 2, x minus root 7, and x plus root 7. Okay, so now I'm going to multiply these out. I'm first going to multiply these two together. So when I do x times x, I get x squared. When I multiply these two together, I get plus square root of 7 times by x. When I multiply these two together, I get minus square root of 7 times by x. And then when I multiply these together, I get minus 7. But these are like terms that will cancel, so I get x squared minus 7. And I still have this x plus 2. So now I need to multiply these together. So x squared times by x is x to the third. X squared times by 2 is plus 2x squared. Negative 7 times by x is negative 7x. Negative 7 times by 2 is negative 14. And there is our answer right there. So this is the function that will give you these zeros. Okay. All right, and I think that's all I'm going to do for this homework assignment.